In this example, we're trying to find out whether this is an odd function or an even function or neither. So the things we need to find out is what is the function of minus x and what is the minus function of x. Let's do this one first. Here I just need to sub minus x in anytime they've used x up here, which means I need minus x squared. I need minus 2 lots of minus x plus 1. See how I've used the brackets there to substitute minus x in each time just to make sure I don't mess up any of my signs. On the next line, tidy it up. Minus x all squared is just x squared, which is looking a lot like what we had up here. But this bit's going to be different because minus 2 times minus x is plus 2x plus 1. So I can clearly see here that this is not the same as that. There's a sign difference here, and they're not equal. So what I've found is that the function of x is not equal to the function of minus x. Now, if it was, I would have an even function, but it's not, so I can say it's not even. Now, to look for an odd function, I'm looking to see whether the function of minus x might be the same as the minus function of x. So I've got the function of minus x here. I'm going to just put that in here to make it really clear that I have that one already. And the next one I need to find is the minus function of x. Now, this means that you're just going to put a minus in front of the whole function of x, which effectively means that you're multiplying all of this by -1, so you need to multiply all of this by -1. It's like putting a minus bracket outside the whole function. Can you see that this is the same as that first line? Because both sides have been multiplied by -1. At this point, I can tidy it up and expand my brackets to see that I've got minus x squared plus 2x minus 1. Now, having a look, I can compare this to the original function. It's not the same as that. But more importantly, I'm looking to see whether the function of minus x might be the same as the function of the minus the function of x, this way around. Because if it is, this will be an odd function. Now, having a look, this is not equal to that. So I can say it's not equal, therefore the function is not odd. So, therefore, the function is neither odd nor even. Once again, we're checking to see whether this function is even or odd or neither. So first thing I always check for is whether it might be even. So I find the function of minus x, and that means I need to substitute minus x in any place that they have x up here. So for the first term, I have minus x, which just gives me x. And for the second term, I've got 3 to the power of not x, but minus x. Now you'll notice straight away that these are both exactly the same. The terms are just switched around in a different order. So I can see that the function of x is in fact equal to the function of minus x. And that tells me that it is an even function. Now when you find that something is an even function, do you need to go on and check if it is also odd? Well, the only way that something can be an even function and an odd function is if it's a circle with its centre at the origin. And if you think about it, it makes sense because this part of a circle, if you take this bit here and reflect it across the y-axis, it will land here, making it even. In fact, let's draw a whole circle. It could be a circle or a semicircle. But at the same time, if you take this part of a circle and you rotate it 180 degrees, in fact, take the entire circle and rotate it 180 degrees, it's going to be completely unchanged. So a circle is even or odd, but it's the only sort of graph that can be. So given that this is clearly some sort of exponential graph, I can see that it's not an odd function. If you wanted to be really thorough and just make sure, you would find the negative function of x, which just means that you need to basically multiply both sides of this equation by a negative. So we've got a negative function of x here, and we need to multiply this entire part up the top by -1, which when we tidy it up, just means that we'll have -3 to the power of minus x minus 3 to the power of x, which is clearly not the same as the function of minus x, so it's not odd as we expected. Another example here of trying to work out whether a function is even or odd or neither. First step is to find a function of minus x, which means we need to sub minus x in anywhere that x has been used in this equation. So that gives us minus 4x on the top, or if you'd like to go a little bit slower, it's 4 lots of minus x, which in my head I've pretty much just said, well, that's minus 4x. And on the bottom we have minus x all squared. Now I know that when I square minus x, I get this exact same thing as x squared. So I end up with this. Now these are not the same because clearly we have a negative on the top here. So I can write that function of x is not equal to the function of minus x, therefore it's not even. Now to find if this might be an odd function, I need to test the negative function of x. And that means I need to multiply all of this by -1 and therefore all of this by -1. Well, that's looking pretty good because if I multiply all of this by -1, I'm going to get not 4x on the top, but minus 4x over exactly the same as what's on the bottom. So I can see that this is the same as the function of minus x. And if the function of x is equal to the function of minus x, then we have an odd function. And I can write clearly it is odd.